Example 1. Solve 4x squared plus 3x minus 3 equals 0 by completing the square. And you'll notice completing the square is a technique we've already learned this year. The technique is what it was before. Up till now, the lead coefficient has been 1. It's been 1x squared. Now it's 4x squared, and that makes it different. And the first step on the process back when we first learned completing the square said, make sure the lead coefficient equals 1. Alright? So, what I'm going to do is I'm going to make sure the lead coefficient's 1. And the way I do that is I divide everything by 4. Even if it doesn't divide nicely. I still have the descending order equal to 0. That's important. But I do not want to have anything but 1x squared when I complete the square. So, if I divide everything by 4, I'm left with x squared plus 3/4 x minus 3/4 equals 0. Alright? After you've done that, you get the lead coefficient of 1. Completing the square is what it was before. I'm going to move the constant to the other side. When I do that, notice I left a gap there to allow myself room to complete the square. Now, almost always when you get a lead coefficient, you're going to have a fraction right here. Almost always. It just happens because it's very seldom does that number that's right there nicely divide into everything. Sometimes it does, but usually it doesn't. So expect fractions to happen here. 2 ways to make half a fraction. All right? If the top is even, we're going to do half the top. If the top is odd, we're going to double the bottom. One of those two things is going to, the bottom number is irrelevant, all right? When you're making a decision, how am I going to take half a fraction? If the top number is even, I take half the top number. If the top number is odd, I take double the bottom number to make half the fraction. So, in this case, notice the top number is odd, right? So when I complete the square, I'm going to take the bottom number double. 3/8 is half of 3/4. All right, so again, that's half of 3/4. And again, there's no thought process beyond odd and even. That's odd, double the bottom. That's how you take half of it. All right? I'm supposed to square that. Now, when there's a fraction present, that's how I do it. I write on that side 3/8 squared, because the very next step I'm going to take the square root of it anyway. So why do I need to multiply it out? All right, there's no need. On this other side, though, I'm going to do plus 9/64. And the way I did that, I simply multiplied the top by itself, the bottom times itself. 3 times 3 is 9, 8 times 8 is 64. Notice I also left myself a gap here, because I need to add these two fractions together. And if there's fraction addition happening, I need to make sure a common denominator is there. So, 3/4 needs to be multiplied by what to make 64?
16.
16, right? So, this has become 48 over 64. All right, 3/4 and 48 over 64 are the same thing. 48/64 is much more useful to me because it has the proper denominator for addition of fractions to happen. All right? So, descending order equals 0. Divide everything by lead coefficient. Get the constant isolated. Complete the square. Create a common denominator. Then we're going to factor this. This side here, the x squared side, is always going to be a binomial squared. It's always going to have whatever sign the middle term is in the middle. So it's positive 3/4, so I put a plus. And it's simply the square root of these two perfect squares. All you have to do is take the squares off of them. Square root of x squared is x, square root of 3/8 squared is 3/8. The right-hand side, we've already got a common denominator, so we can add to the numerator, so 48 and 9 make 57/64. Now, I'm going to make a note here. Once you've done this step, and you factor the left-hand side, you've added the right-hand side together, let me just make one simple note here. Never, hang on, I've got to make this more bold. Never reduce this. You want to reduce up in this step or this step, that's fine. Even in this step, that's fine. Never, ever reduce this. Exclamation point, exclamation point, exclamation point. Box around it, underlined several times. There we go. Never reduce that. Ever. Never, ever, 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 ever reduce that. saying English words here. Do not reduce that fraction ever, not even once. Not even on Thursdays in December. Don't reduce that fraction, ever.
But sometimes.
Never reduce that fraction. Okay, please, for my sanity, do not reduce that fraction. Every year I say the same thing and 3 or 4 people still reduce that fraction because they just want to get up my nerves, I think. They're like, let's see what happens to decline if I reduce this fraction just for fun here. I want to be around when he's grading this paper. That'd be great. Don't be that person. That makes me very unpleasant. Okay, anyway. Don't reduce that fraction. Reason why. Very next step, we're going to square root things, right?
No.
Notice that this is a perfect square because we squared it, right?
No.
Our common denominator is also that same perfect square, right? So the denominator of this thing's a perfect square. So notice when I take the square root of this thing, what's the square root of 64?
8.
8. If that happened to reduce, let's just for craziness, say that's 2 over 64, makes 1 over 32. What's the square root of 32 off the top of anybody's head?
9.
Nobody knows, right? So don't reduce that fraction, please. All right. And I put a plus or minus. No, the square root of 57, I have no idea what it is. It stays square root of 57. The bottom, square root of 64 is 8. Since I did square root the bottom, notice there's no more radical over that. The square root ends there. So the top is square rooted. The bottom has also been square rooted, but we actually evaluated that. And over here we have x plus 3/8. We took the square root of the left, so the square goes away, square root of the right, get the plus or minus square root object. Final step, we simply need to get x equals. Now here's another thing. I've said this, and some of you are still doing this improperly. Put that in front of the plus or minus sign. Don't put it over here, put it right there in front of that. Notice they have a common denominator. That's pretty typical. They usually do. So when I move that over, if I just make this big divided by 8 situation going on here, I'm going to have a 3 moving. That's a positive 3, right?
No.
So it becomes negative 3 on top. And then I got the plus or minus the square root of 57. And there's my nice answer to the problem there. So let's do this. There we go. So descending order equals 0, ready to go. Lead coefficient needs to be 1. Divide everything by 4, makes it happen. You do not want a constant on this side. Move it to the other side. Half of 3/4. 3 is odd, so we double the bottom. 3/8 squared. 3 squared is 9. 8 squared is 64. Common denominator, 48 and 9 make 57. 64, not reduced. Or do not reduce. X plus 3/8 squared. Square root. Perfect square, so we get an 8 on the bottom. Common denominator, again, almost always happens. Stick them together into a single fraction in that one step.